RoboPapa.
Hey YouTubers, this is RoboPapa. In today's episode I want to kind of show you how to use Arduino with a couple of sensors and motors and the shields that actually belongs to it. It probably will be two or three parts. That way it will not be too long and you can skip ahead or go to the video that you like. But I will start with basically setting certain sensors with the pref board or breadboard, and after that we'll move towards the motors and the motor shield with the certain chassis, and then we'll combine everything together and see how it's in action. So let's get started. So today's episode will do the sensors, and the sensors that I'm using are a ping sensor, which that is one of the sensors that you can see. It's got 4 pins over here. Let me try to zoom in. That will be easier for you guys to see that. So it's got 4 pins over here, which is power, ground, and then echo and trigger in the middle. It's very similar to the ping sensor, with the exception that this one has a dedicated GPIO for the echo and a dedicated GPIO for the trigger, unlike the ping, which is the same one. So that's something that we'll need to worry about when we start coding with that. And I have 2 of them. Oops. I got 2 of them. That way we can actually mount it into the chassis or a certain vehicle and get like a better range. Not just one that goes straight, but we can now look on 2 different directions and decide, are we near a wall or a corner, or just determine how we want to move with that. So we got those. Obviously we have a lot of jumping wires that we will need. We got our breadboard that we'll be able to use and utilize. Don't worry about this one. This is something that I will do like in future episodes that will help you with your breadboard. Obviously we will need the Arduino. I'm using the Arduino Uno. That's the original one. And I'm using this shield that is really for the Arduino, and it comes from Saint Smart. I don't know if you can see it. For some reason my camera doesn't like to focus very fast. So it's from Saint Smart, and the nice thing is that all the GPIOs are actually already hooked up over here, and you have also the analog ones. So the digital ones are here, the analogs are here, and you can still stack other shields on top of it because it's the stackable one. Let me try to see if I can zoom in a little bit, that way you can see better. There you go. So you can see all the GPIOs are over here, and then we have the reset button as well. So we'll use this shield to actually set the ping sensors, and obviously a USB that connects to the computer. So really all the ping itself is doing is sending a sound signal, and then when it hits something it bounces back to the trigger, to the echo one, and then you can calculate the distance. So it's really just how time and the sound travel, the speed of sound. Then you can calculate because of the duration, you can calculate the distance. So let's set up some small example. That way we can see how it works. And then we'll go also on the software side of how to utilize that. Alright, so I start to set up a test area for us to, that way we can see the ping, how it works and if it works. So we have the ping sensor over here, and I have a ruler for 12 inches or 30 centimeters. The ruler starts from the beginning of the ping, that way the signal actually comes out from here and it returns to here. So this is the distance that we're going to measure. And the ping by the documentations is actually can go all the way to 100 centimeters or even more, but for now we will just test it on 30 centimeters. But we will need some indication for how far the ping is or how we calculate a distance. So one thing is we're going to use an LED, a yellow LED over here, that as the distance go further, it will get brighter, and as you get closer to the ping, it will get dimmer. But also I'll use the liquid crystal to output actually the distance over here, both in centimeters and inches. And I already connected that to the shield, the sensor shield. And I followed just this schematics over here of how to connect, which I found online. Just Google the liquid crystal and you'll be able to find an image that basically tells you all the outputs. And I can post this also on my website, that way you will have it if you need to. So there's this version that really takes the liquid crystal and shows you how it's connected to the pins on the Arduino. Or if you like more of a graphical coloring, you can see over here with all the wires and how they go. So I already connected and I ran the example on the Arduino software, and you can see, I don't know if you can see over here, let me try to zoom in. It's just a simple hello world that's supposed to output to the crystal. And right now you cannot see anything, and that's why you have the pod over here. That way you can actually control how much dim it needs to have, or backlight. And now you can see that we actually have a count over here. It says hello world and start counting the ticks over here. So we will use this to actually indicate how far we are. So we'll go and connect the ping. Okay, so we'll move to the code, that way we can actually start making the LED and the screen showing us the distance from the ping sensor. So I have over here a brand new sketch from just started the Arduino IDE, and what we will want to do is import the liquid crystal, that way we have the reference. That way we can actually connect to the liquid crystal screen. I created also my own library for the ping, which I'll show you right now. It's a very straightforward one, nothing too fancy about it, but it will help basically seeing what it is and simplify the code. That way you don't need to do too many things. So here's the CPP, or the .h for the ping itself. The beginning is just like a regular declaration of what Arduino we using, and then I defined a couple of constants or variables. The main ones are the centimeters factor and inches factor that we will use to calculate the distance. Really, we just sending two pins, two GPIOs, one for the echo, one for the trigger, and then a boolean to say if we want inches or centimeters. The constructor itself, that's what it takes over here. As you can see, we have echo, trigger, and these inches, and then we'll calculate the distance. So if we look on the CPP, where the meat of it is, once again, we're getting the echo, the trigger, and the is inches, and in the constructor we're assigning to those private variables. And then if it's inches, the factor will be inches factor, Otherwise, it will be centimeters factor. We also set up the pin mode for echo and trigger to be input for the echo, and the trigger is output. So when we trying to calculate the distance, we're sending a signal with the trigger out, so it sends the sound, and then it's listening to echo as the input to see and calculate the distance, or to kind of like stop that sound counting. The function distance is really that's all it does. It's sending up the trigger to low. We're waiting for 2 microseconds, then you send it to high. That's basically initialized and trigger the ping to send the sound. We're waiting at least 10 microseconds, and then we're setting the echo to be low, because the pulse in, we're looking for it when it gets high. When echo pin will become high, we know that the sound came back. And that's the duration, which I have some misspelling over here, but should be duration. And the duration really, if you think about it, it's the duration of going to the object and then coming back, which means that if we want to calculate the distance, now we have double the distance, so we need to divide it by 2. We have the factor itself, which actually comes from the help file of the ping itself, which is the HCSR04, and they declared over there, and they said that for centimeters it's supposed to be 24, I believe, or 29, and inches is 74, and that will give us the duration, or really it's just the distance at this point, and that's what this function is returning. So if we look again over here, so we using the liquid crystal as the library, and we'll add also, which I have it over here, our ping sensor, and that's just including those libraries, that way we can use them. What we need to do now is really to declare the liquid crystal, which pins it's using. So we'll do liquid crystal, and we'll call it LCD, and we're sending it 12, 11, 5, 4, 3, and 2. And this is by the default. If you look on the examples for liquid crystal and hello world, it's actually setting up to the same ones, the same pins. And then we'll make another, we'll make one object of our ping, which is HCSR04, and we call it ping HCSR04. And what it requires really is, like I said, it's 2 pins, the echo and the trigger. So we'll use pin 10 for the echo, pin 9 for the trigger, and let's say that we want it in inches, so we will send true to it. So now we have these 2 objects that we can actually work with. So first thing, we'll need to initialize the LCD to tell it to begin, and we want 16 characters on 2 lines. And we'll print it, let's print something out, that way we know that we're actually communicating something. So set ping for inches. We said that we want the light, the LED, to do something, that way we can see it with that as well. So let's just declare over here an LED pin. We'll connect it to pin number 6, because that's the one that can do PWM, pulse width modulation. So we can now declare that pin as an output pin. And I think that will be it for the setup. And really in the loop, all we need to do is we'll set up the cursor for the screen to go to the next line. And now we will basically take the distance from our ping dot distance. So that's the nice thing about having that library, is just that basically you're writing it once, now you can reuse it. You don't need to copy the code again and again. So now we will get the distance in inches because we set up over here the true. If this was false, it will be actually in centimeters. So we will print out from the LCD, we'll print out distance and LCD.print and distance. Oops. Let's do this instead. That way we'll actually have it. And now what we want to do is actually, let's say that as closer as you get to the ping sensor, the LED will be dimmer. So what we want to do is analog write. We will do LED pin. That's what we want, we want to write to. And now I'm going to combine a couple of methods that are within the Arduino. So the first one is map, and I'll explain a little bit about them in a second. The other one is the constraint. So the constraint is actually taking distance, and according to the documentation, the ping itself can go from 0 centimeters to, I believe it was 5 meters that I read. Let's see let me pull up the web page real quick, and we can see what they have over there. And I can post this link on my webpage. So over here you can actually see what the qualifications that they need. The 5-volt DC, the resolution is 0.3 centimeters. This is something that it's very important. Measuring angle is 30 degrees, which means that way you will not have interference with other ping sensor, or that you will not think that it actually can have a wider range. So the ranging distance, it's between 2 centimeters to 4 meters, or 1 inch to 13 feet. That's a pretty cool and pretty long distance that it can actually look for. And you can see over here they're giving you all the information that you need in order to know. Let's see, I'm trying to think. So you can see, yeah. All right. So we said between 1 inch to 3 feet. So if we take the code and we say the distance can actually go between basically, can go between 0, let's say 0, or even 1, and we'll give it a limit of 24 inches, which is 2 feet. So what the constraint does is, if the distance will actually come bigger than that, it will constrain then on 24, and that result will be the initial value of the map, or the value that we want to map at 2. And now for the map, you're giving it basically 2 values, or 4 values, 2 pairs of what is the minimum value and the maximum value, and what is the minimum and maximum value that you want to go to. So we're saying that our range basically is from 0 or 1 to 24, and that should be mapping to 0 to 255. And the reason is that 255 is because the analog write is ranging from 0 to 255. And that's basically it. That should actually output our distance in the crystal, the liquid crystal screen, and the light should actually dim as I'm moving the object or my hand closer to the ping sensor. So I uploaded the code, and you can see the LED is already over here, pretty bright. And I don't know if you can see the screen and what it says, but it basically jumping on the distance over here, because it doesn't see an object, so it kind of like bouncing back and forth. But if I'll put my hand, which is in the end of the 12 inches, you can see the LED start to dim as I'm getting closer and closer to the ping itself. So here's the full brightness, and now it's dim, and as I'll go back, you can see that it's getting bright again. And the same thing will be with the screen. You can see that it's 11, 10, 7, 4, all the way to 1. And I can actually go further than that. So now the screen says 23 inches. Now it says it's jumping to 29 and 30. It's like 34, 35. And I can go back again. Okay. One last thing I want to show you guys is actually this little board that I made with that LED over here that indicates that there's power to it. And it's basically just a simple board that I created. If I try to show it to you over here. There you go. And I just have an LED over here, and the resistor obviously for it, the pins for the ping that goes to the Arduino board, and then the ping itself is just connected over here. There's an extra pin over here, there's 5 pins, and this one is just for an extra power, or an extra 5-volt rail for the LED. That way I know that it's actually getting power. And that's what I have over here. So it's a nice little board that I just created. Alright, so that's for it today, for this episode. Next episode we actually will take the shield for the motor, and we will connect that shield with let me show you the shield real quick. So this is a motor shield from Adafruit. It's their version 2, and we'll connect that to the motors, and we'll control them from the Arduino. And the episode after that will actually combine all of that together, or maybe I'll actually be able to do that in one episode. We'll combine all of this together with the ping sensor, which will determine like where we are, how far are we from obstacles, and then run the motors accordingly. Right? If you like it, please like and subscribe. And if you have any questions, leave it in the comment, and I'll try to answer you with my best knowledge. Thanks, guys.